John was born on a Wednesday. Allison was born on 72 days later. On what day of the week was Allison born? Sunday, Monday, Tuesday, Wednesday. We'll make this little calendar here. And then John is born Wednesday. So he is born right here. Now, 1 day later is a Thursday. 2 days later is a Friday, and so on, right? 4, 5, 6. So if I said 7 days later, you'd say, okay, that's easy. That's a Wednesday again. But it's not 7 days. It's 72 days. So we got to figure this out. Well, the good news is that if you just keep counting by sevens, 14, 21, and so on, right? Then all of those are Wednesdays. So 35, 42, let's get sufficiently close to 70. And if you do 56, 63, and then 70, then we get to Wednesday. So if the question was 70 days later, it's just going to be a Wednesday, but it's not. It's 71 days later. 72 days later, actually. So the 71st day would be Thursday, and then 72 days later would be a Friday. So number 11, the answer is E. The letters A, B, C, D, E are to be placed in the grid so that each of these letters appears exactly once in each row and exactly once in each column. What letter will go in the square marked with an asterisk? Well, let's concentrate on this column first. It has A, E, B. It doesn't have a B or it has A, E, B. Doesn't have C or D. Well, C can't go here because C is already here and it can only appear once in each row. So C obviously has to go here, and therefore D will go there. That takes care of that. Now let's see, where can we go? A lot of ways, different approaches to this. I'll just go here in that row. That has A, D, and C. It doesn't have B or E. E can't go here because E is already there. E can only appear once in each column. So that means E must go here. And therefore the only letter that's missing is B. So B goes there. All right, where do we go next here? I guess we can look at this column. It has A, C, D. It doesn't have B or E. E obviously cannot go there since it's already in that row, so E must go here, and therefore B goes here. And then I guess keep going with that same strategy. In that row, we have A, B, E. We do not have C or D. C cannot go here because it's already there, so C must go here, D must go here. And I think, where do we go next? I might as well try this one. That is missing an A and an E. E cannot go here, obviously, since E is already there, so E must go here, and therefore A goes here. I think finally we're ready to tackle that row. It's missing a B and a D. It's missing a B, or B cannot go here because there's a B up there, so that must mean that B is here, and therefore D is there. So finally, the asterisk is B, and therefore that means 14 is B. Daniel begins with 64 coins in his coin jar. Each time he reaches into the jar, he removes half the coins that are in the jar. How many times must he reach in and remove coins from his jar so that exactly one coin remains in the jar? Initially, he had 64. Every time he reaches in and takes out half. So he'll take out 32. 32 will remain. Then he reaches in, takes out half, which is 16. 16 will remain. Then he reaches in, takes out half, which is 8. 8 will remain. And so on. 4, 2, and then 1. So they're asking how many times did he reach in the jar? This was the first time, second time, third time, fourth time, fifth time, and sixth time. Each time he reached in the jar, he took out half, and the next number is what's remaining. So they're saying, how many times does this happen before we get to the scenario where only one coin remains? Well, 1, 2, 3, 4, 5, 6 times he had to reach into that jar and repeat the process. So number 15, the answer is 6, which is C. The product of 3 consecutive odd numbers is 9177. What is the sum of the numbers? The first thing we need to do is break up this into its prime factors. You're allowed to use a calculator on the Canadian exam, so get it out. And when you do, you'll find it equals 3 times 7 times 19 times 23. Well, if we combine the 3 and the 7, it becomes 21 times 19 times 23. Now, are these three consecutive odd numbers? Yeah, 19, 21, 23 are consecutive. So there you go, those are the numbers. And if you want the sum, you just add 19 plus 21 plus 23, and that is, of course, 63. So number 20, the answer is D. In the sequence shown, each figure after the first is formed by adding 4 squares to the previous figure. How many squares form figure 2010? So we have the first figure, second figure, third figure, fourth figure, all the way down until the 2010th figure. Now what I want to do is sort of just get a general formula for any n, for any value. So let's talk about this. The first figure, there's just one square. Next figure, it's 1 plus 4. Next figure, it's 1 plus 4 plus 4. So each time you're adding 4. So the fourth figure would be 1 plus 4 like that. So generally speaking, for any n, the number of squares would be 1 plus n minus 1 times 4. And you can see that is definitely going to be the general formula. So when n is equal to 2010, we can substitute 2010 into our general formula, and that would be 2010 minus 1 times 4, and this is equal to 8037. So number 19, the answer is A. The list 2x, y, 5, the sum of any two adjacent numbers is constant. The value of x minus y is 2x, y, and 5. So the sum of any two, whether it's that plus that, that plus that, or that plus that, is the same. So that basically means that 2 plus x is the same as x plus y is the same as y plus 5. Okay? From this equation, I basically get that 2 is equal to y because the x's cancel. From that one, the y's cancel, and I get x is equal to 5. That's it. So I just have to now figure out x minus y. That's going to be 5 minus 2, which is 3. Number 13, the answer is C. Jim wrote the sequence of symbols a total of 50 times. How many more hearts than spades symbols did he write? If you look at that original sequence, there's 9 symbols, right? And of those 9 symbols, 5 are hearts, and 2 are those spades, however you draw them, and 2 are diamonds. So if we are going to write them out 50 times, then basically you would be multiplying those by 50. So you would get 250 hearts, and you would get 100 of those spades, and you'd get 100 diamonds. So they're saying, how many more of these hearts are you going to have than these spades? Well, there's 250 hearts and 100 spades, so 250 minus 100 is 150. And that is the answer they are looking for. Number 11, therefore, is B. In the table shown, a sequence starts with 2 in the top left corner moving across each row. Each box is filled with a number 3 greater than the number to its left. The leftmost number in each row is 3 greater than the greatest in the previous row. When all of the boxes are filled in, the value of x is. Here's x right down there. Now what's happening is you got 2 plus 3, then plus 3, and plus 3, and it kind of keeps on going, right? So every number is going to be 2 plus some multiple of 3, 3n, every number. So for example, this is n equals 1, n equals 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when n is 12, it will be 2 plus 3 times 12, and that is 2 plus 36. And that is how we got that 38. So just keep going. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 35 is what I have to put for n to get x. So 2 plus 3 times 35, and that's what x will be. So this is going to be 2 plus 105, and that is 107. So number 12, the answer is C. A sequence of figures is formed using tiles. Each tile is an equilateral triangle with side length 7. The first figure consists of one tile. Each figure after the first is formed by adding one tile to the previous figure. The first 4 figures are shown. How many tiles are used to form the figure in the sequence with perimeter 91? Let's make a little, not necessarily a table, but a list. So this is one tile, so the number of tiles, I guess. This is 2 tiles, 3 tiles, 4 tiles, and so on, right? 5 tiles, ... And then how many sides does each have? That will give me an idea of what is the perimeter. So this one has 3 sides. So 3 times 7 is the perimeter, which is 21. This has 1, 2, 3, 4 sides because we're looking at the perimeter now. So that's 4 times 7. This has 1, 2, 3, 4, 5. 5 of those 7s. I think that's a better way of saying it. And this one has 1, 2, 3, 4, 5, 6 of those 7s, and then so on. So you kind of see a very clear pattern. This would most likely be 7 times 7 for the perimeter. So this is the perimeter. So now we want to get to a perimeter of 91. So 91 will be obviously something times 7. So something times 7. And if you divide 91 by 7, you get that is 13. So this is a 13 by 7 perimeter. And the number of tiles, if you notice, there is a relationship between the number of tiles and how many times you had to multiply 7. The number of tiles is always 2 less. So if this is 13, the number of tiles would be 11. So just be careful there. Number 14, the answer is B. Toothpicks are used to make rectangular grids as shown. Note that a total of 31 identical toothpicks are used in the 1 by 10 grid. How many toothpicks are used in a 43 by 10 grid? Okay, well, you're obviously not going to draw out 43 by 10 grid. So we have to come up with some sort of a pattern. The pattern is not too difficult. First, let's just look at the 1 by 10. When you have a 1 by 10, you can clearly see that you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of those sticks that are vertical. So the reason it was 11 is because it's 10 plus 1. Okay? So we have 11. But how many of those rows are there? Well, there's just only one row. And in this case, it was 1. So 1 times 11. But then we also have to count the horizontal ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those. So we have to add to that 10, but we have to add both rows. So 2. This is how I have to figure this out. So that's 20 plus 11, which is 31, and that's what they told me in the question. Okay, so far, perhaps I don't know what the formula is, because eventually I want a formula for n times 10, and I can use that to figure out 43 times 10. Okay, here we go. Next one. I've got to put, again, same sort of story, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, but this time I've got to do that twice, right? Okay, so 11 times 2. And then I've got to add to that all these horizontal ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I've got to do that 3 times. These guys, and these guys. So it's going to be 3 times 10. And then there was that 2 times 11. And then what does this equal? 52. Okay, let's just do one more and hopefully you'll get a pattern. For the next one, same sort of story. It'll be 4 times 10 plus 3 times 11. And that turns out to be 73. Okay, now let's try to figure out a general formula for n times 10. As I hope you can see so far, it will be n plus 1 times 10 plus n times 11. That is my general formula. And I hope, because I gave 3 examples, that you can see how I came up with that just by following that pattern. Okay, so if you're convinced that this is the formula, let's plug in 43. So 43 times 10, that kind of a grid. And n is now 43, so it would be 43 plus 1 times 10 plus 43 times 11. So this is 44 times 10, which is 440. 43 times 11 is 473, and then adding those together, you get 913. So 913 toothpicks are used in a 43 by 10 grid. So number 20, the answer is A.